I think in your CET weightage, if you see the list, you will see that the majority of the marks is being divided into the chapters electricity and magnetism, and associated with it the alternating currents, electromagnetic induction. So together they constitute some around say 20 to 25 marks. I think you might have gone through the previous papers, right? So that's why. And also we have when I see many students, usually they find very difficult in electricity and magnetism. It's not because that it is very complex. The thing is, the notations are very new to you. You have not been used to those notations, right? So that's why it appears little complex, but actually it is not at all complex. It is also a quite simple part of the physics. So that's why I thought today we shall discuss about the magnetism. See, in your current syllabus, predominantly 3 chapters are there. One is the moving charges and the magnetism. The second chapter is the magnetism and the matter. And the third one is the electromagnetic induction. So I'm concentrating today the first chapter, that is the moving charges and the magnetism. See, in that chapter also, if you clearly read it, it can be divided into 3 parts. The first part is about the discussion of Lorentz Law, that is the magnetic field induction and related to that. The second part is Biot-Savart's law and Ampere's law. So that application into the solenoid, toroid and infinitely long conductor or a wire. The last part is the galvanometer. So we shall take each topic, we shall discuss and we shall solve the problems. See, the first, you have to understand, I will take a test charge, that is Q. Okay. Now for this test charge, I will say, I will just take this as the reference point P. And from here to here, let the distance be R, vector R. Okay. Now, what is the force due to this test charge at the point of observation P? It is F is equal to Q times the field E, QE, where E is the electric field vector, which is why electric field is present, because a charge is present. The moment a charge is there, there is a field near it. At this point, if the field is E, therefore F is QE. And what is this E? Well, you know, in your electrostatics, it is given by E is equal to 1 by 4 pi epsilon naught Q divided by R square, and R cap because it is along the direction of the vector. Now, this is a static charge. Now, let this charge starts moving in a direction. Okay. So let this charge starts move in the direction. Let V be the velocity of it. Now, the moment it starts moving, a charge starts moving, simultaneously a magnetic field is generated, or a magnetic field induction will be taking place. So what will be the direction of the magnetic field induction? As you know, by the Fleming's left-hand rule, see, if the middle finger is the direction of the velocity vector, then this is the direction of the magnetic field. Means if the charge starts moving in this direction, the magnetic field will come out of the pole. That is the direction of the magnetic field. This constitutes a plane, this V and this B. I cannot write this third dimension. So what I will write is, I will just mark it as say some into mark. Okay. So this constitutes a plane. Okay. For this plane, perpendicular to this plane will be the magnetic force Fm. So whenever a charge starts moving with the velocity, if you apply the Fleming's left hand rule, this is the direction of the charge and the direction of the magnetic field is penetrating out of the board to the plane containing this V and B, to the perpendicular direction will be the magnetic force acting on it. So what will be the mathematical equation for this? This is given by the Lorentz force Fm, which is Q into V cross B. Therefore, Fm is equal to Q V B sine theta. V cross B is VB sine theta. So therefore, here you must see that the direction of the force will always be perpendicular to the plane containing the velocity of the charged particle and the magnetic field. See, the theta between the V and B, it can take any angle. This V cross B, which is VB sine theta, this theta can take any value from 0 to pi by 2 or even pi. But the Fm, it can never take any other direction other than the perpendicular direction to the plane containing the B and B vectors. Now, what will be if theta is equal to 0? What is the meaning of it? If theta is equal to 0 means V and B both are along the same direction. And this will be the F. So what will be the F when V and B both are in same direction? The magnetic force will be 0. And when V and B are perfectly perpendicular to each other, the direction of the force will be perpendicular to the plane. Then this Fm will be maximum when theta is equal to 0, for which Fm will be QVB. This is for theta is equal to 90 degrees. Now together, when a charged particle is static plus when charged particle starts moving, the total combined electric force and magnetic force together constitute for Lorentz force. This F Lorentz is equal to Fe plus Fm, which is equal to QE plus Q into V cross B. I think this is not visible to you. I will write here. So the Lorentz force F is equal to QE plus Q into V cross B. So this constitutes the electric component and this constitutes for the magnetic component. Now, having said these terms and all, now I want you to draw on your attention on the term, this term B. See here, you you are aware of the velocity vector and this B, the magnetic field induction. The magnetic field induction, see, this magnetic field induction vector B, what is the speciality of this vector? The speciality of this vector is, it is that vector which changes, which exists in such a way that force is dependent on velocity. See, if you take any other force, for example, if you take gravitational force, it is G m1 m2 divided by r square, where two masses and the distance. It is not dependent on velocity. If you take electrostatic force, that is also not dependent on velocity. It is only dependent on the charges and the distance. And the third one, that is the nuclear force, even that is not velocity dependent. But the only force which is velocity dependent is the magnetic field induction vector, which makes the force dependent on velocity. See, because of this vector, the force will be dependent on velocity. And here, one more thing you should note down, that this force can never change or alter the magnitude of velocity. It can, because if you know, this F is always perpendicular to V, this force can never change the magnitude of velocity. It can only alter the direction of the velocity. That's all. It can only alter the direction. So therefore, the speciality of the magnetic field induction vector is, it is that field which makes the force a velocity dependent force. So that is the speciality of the magnetic field induction. Next, now let us see what will be the unit of this magnetic field induction. Okay, so we shall take this F is equal to QVB, where we have assumed that the B and B are exactly perpendicular. Therefore, F will be QVB. Therefore, B will be F divided by QV. The F will be what? It will be Newton divided by Coulomb. Velocity is meter per second. In CGS unit, what you will write? This Newton is nothing but Gauss, Coulomb. Actually, in CGS unit, it is called apt Coulomb. Okay, then this is centimeter per second. Sorry, this is dyne. This is dyne. So therefore, B is equal to, in SI unit, the unit is Tesla. In CGS unit, it is the Gauss. And 1 Tesla is equal to 10 power 4 Gauss. And now how you got this? Because this dyne, 1 Newton is 10 power 5 dyne. and this coulomb is 1 by 10 and this meter is centimeter per second, 1 over 100. So together constitutes 10 power 4. Therefore, 1 Tesla is equal to 10 power 4 Gauss. And next thing, we shall understand one concept and later we shall solve few problems related to this. Now, there is one question in the previous papers, and even you might have studied that. They say, the thing is, we say that there will be no work done by a magnetic field. When you move a charge in the magnetic field, there will be no work done. So why? Well, what is the reason behind it? Now, for that, if you just F is equal to Q into V cross B. Okay. Now, what is work done? Work done is nothing but force into displacement. So, force into displacement is nothing but velocity into time. I can write it as F dot B into dt. Now here F dot B means, as you know, B is always, force is always perpendicular to the velocity component. It will be 90 degrees. So F dot B means FB cos theta cos 90. So it will be 0. Therefore, work done is 0. So work done is equal to 0. What is the inference of it? The inference of it is, in a static magnetic field, when you move a charged particle, you can only change the direction of it and you cannot change the velocity of it. And also, the kinetic energy will remain constant. I will give you an example. See, for example, if a proton is moving in a magnetic field. Now, in a magnetic field, when a proton is moving, obviously the magnetic force will impact on the proton. When the magnetic force impacts on the proton, it will just change the direction, but the magnitude of the velocity is not changed. So that is the important inference of this. Work done when moving a charged particle in a magnetic field is 0. The meaning of it is, when a charged particle is moving in magnetic field, only the direction of it will be altered, not the velocity of it, the magnitude of the velocity of it. See, we may think that these are all things are just mathematical. Now, if you apply these to actual physical phenomena, you will be just wonderstruck. For example, if a coil in a current is moving in a coil, see, all our home will be electrically wired, right? And when the current is moving, obviously magnetic field will be generated. Now, if this magnetic field can influence the velocity, the magnitude of velocity also, then the moment you set the current, it will be just keep on increasing. Why? Because the velocity of the charged particle increases, it will be keep on increasing, and I don't know what will be the effect of it. So it may just exceed the limit and anything can happen. So that's why nature, how it has designed in a way that if a charged particle is moving in the magnetic field, only the direction will be altered and never its velocity. So, and bear one thing in mind, this is only for static magnetic field. For accelerating magnetic field, the entire picture changes. For static magnetic field, the work done will be zero. Okay, and also the kinetic energy of the particle remains unchanged. It's quite easy because kinetic energy is nothing but half mv square. When v is constant, kinetic energy is also constant. So now we shall discuss the problems related to the Lorentz force. See here, the first problem, a proton and a deuteron both have equal kinetic energies. Compare the radius and magnetic field when magnetic field is applied normal to their orbits. So here the problem they have given is proton and neutron they have given. They have same kinetic energies. Okay. When magnetic field is applied what will be the radii of them? So this is the question. Now, one more thing I want you to understand is, see, you have to, whenever you are entering any exam, you should never memorize everything. This formula, that formula, 1, 2, 3, 4, like that. Don't memorize the formula. Keep the basic things ready, and you can derive just in a minute. And here also, there is nothing you have to memorize. What you have to memorize is only the Lorentz formula, which is F is equal to QVB. Okay, this formula you have to understand, and you know what is the centripetal force. The centripetal force is what? It is mv square by r. Okay, and if I don't know whether you know this way or not, you can also write this as m v square r by r square m r omega square. This omega is nothing but v by r. Okay, it's angular velocity. This is linear velocity. This is angular velocity. See, it's just like your linear momentum and angular momentum. Linear momentum is mv, right? Angular momentum is equal to m omega. In the same way, linear velocity is mv square by r. Angular velocity is mr omega square. Okay. Now, if you know these two, the rest you can derive. See, you just equate it. QVB is equal to mv square by r. Now, VB gets cancelled. Therefore, V is equal to QBR by M. Okay, this is one relation. The second relation is R is equal to Vm divided by QB. This is the second relation. Only you have to know this Lorentz force law and the centripetal force, right? Dr. Now, what is, so in same way, instead of mv square by r, I have written mr omega square. This is also centripetal force formula only. So if I write QVB as mr omega square, so omega will be square root of QVB divided by mr. And what is the time period T? T is 1 by 2 pi root of mr by qvt. And you know v, you know r, you know omega, you know t. F is nothing but 1 by t. You take the reciprocal of it. The linear momentum, if they ask you, it is mv. Just multiply m with this velocity. If they ask you kinetic energy, it is half mv square. So you take square of it, multiply by m by 2. It will give you the kinetic energy. Now, how much time it took to derive? It's not less than even 60 seconds, isn't it? So if you know these two equations, the rest you can derive there itself, and you can work out whatever they have asked. Now for the current problem, see the relation is R is equal to Vm by Qb and V is equal to Qbr by M. So therefore, for the problem, see, for the proton, the mass, if I say m, for deuteron, it is 2m. For proton, the charge is q. For deuteron, it is 2q. Okay. So therefore, m, we know that equation B is equal to QBR by M. Okay. So I will represent as BP, which is equal to QP BRP by M, and BD is equal to QD BRD by 2M. This is also 2Q. So therefore, BP by BD is equal to this Q B RP by M divided by 2 Q B RD by 2M. So 2 gets cancelled, Q cancels, M cancels, BB cancels. It is RP by RD. So therefore, BP by BD is equal to RP by RD. Now, since the kinetic energy is same, they have given the kinetic energy of the proton and the deuteron are same. So therefore, half m BP square is equal to half 2m BD square. So m cancels, 2 cancels here. Therefore, BP by BD is equal to root 2 by 1. So therefore, BP by BD is equal to RP by RD is equal to root 2 by 1. So this is the ratio of the velocity as well as the radius of proton and deuteron. I hope this problem is clear to you, or if this step is not visible, I will write here BP by BD is equal to RP by RD is equal to root 2 by 1. This is the ratio of the radii of proton and the deuteron when they both have same kinetic energy. So the next problem . So the next problem is an electron is accelerated by a potential difference of 5 kilovolt. An electron is accelerated by a potential difference of 5 kilovolt, and then in a uniform magnetic field of 4 into 10 power minus 2 Tesla. Determine the radius of the electron in the magnetic field. So for that, as you know, half mv squared is equal to 5 kilovolt. Now they have given the velocity as velocity you have to determine, as well as you have to determine the radius. Okay, so half mv squared is equal to 5 kilovolt. Therefore, velocity is equal to square root of 5 into 10 power 3 into 2 divided by the mass of the electron, that is 9.1 into 10 power minus 31. So this gives you the velocity as 4.2 into 10 power 7 meter per second. Having found out the velocity, next is you have to determine the radius. Now again, I don't remember the actual equation. So what I will do, I will just take QVB is equal to mv square by r. This VB cancels. R is equal to mv by QB. So I derived within a matter of seconds. Therefore, I will substitute here mv divided by QB. The mass of the electron 9.1 into 10 power minus 31 into V, that is 4.2 into 10 power 7 divided by Q, the charge of the electron 1.6 into 10 power minus 19 into the magnetic field, that is 4 into 10 power minus 2 Tesla. So you will get the radius as 5.97 millimeter, or I will write into 10 power minus 3 meter. R will be 5.97 into 10 power minus 3 meter. So regarding the Lorentz force, this is one problem. And another problem, this one actually appeared in Ames entrance. So this problem I want to discuss here. A test charge of Q is equal to 3.2 into 10 power minus 19 coulomb. Okay, a test charge of Q, which is equal to 3.2 into 10 power minus 19 coulomb, is moving with linear velocity. V is equal to 2I plus 2J, okay, meter per second. Okay, see, usually they will give you the magnitude 2 meter per second, 50 meter per second. So they have given vectorially. Along x-axis how much velocity is there, along y-axis how much velocity is there. In a combined electric field and magnetic field whose strength is E is equal to 3I cap plus 6J cap plus K cap. Okay, Newton per coulomb, the electric field. And the magnetic field value is 2J cap plus 3K cap Tesla. Now, what is the Lorentz force experienced by this charge? See, this is actually very simple here. You know that Lorentz force is nothing but QE plus Q into B cross B, right? Now here, Q, E, you just have to substitute and the rest is, vector dot products. That's all. You know what is I dot j, I dot k, like that. Therefore, F is equal to 3.2 into 10 power minus 19 into 2 I cap plus 2 j cap. This is QE. Okay, I will write FE. FM is equal to 3.2 into 10 power minus 19. Here, B cross B, that is B 2I cap plus 2J cap into the cross product of the magnetic field 2J cap plus 3K cap. See, in the dot products and cross products, you should always remember I dot I and J dot J, K dot K is equal to 1. Whereas I dot J, J dot K, K dot I is equal to 0. This is completely opposite in the cross product. I cross J is equal to K, J cross K is equal to I, K cross I is equal to J. Whereas I cross I into J cross J, K cross K is equal to 0. See, it is similar like if you take x-axis and y-axis, x dot y is equal to 0, whereas, 1, whereas x cross y is equal to 0. This is nothing but instead of ijk, you can also take xyz. Both are same. Okay. So therefore, what is I cross j? It is k. And this will become, I think this is not visible to you. I will do it in the, so here done. So Fm will be 3.2 into 10 power minus 19 coulomb. So 2I cross 2j will give you 4k cap. 2I cross 3k will give you 6. See, it is I cross k, not k cross I. So it is the reverse direction. Therefore, minus will come. It is minus 6j plus 2j cross 2j will be 0 plus 2j cross 3k will be 6i. Therefore, the total Lorentz force is equal to 3.2 into 10 power minus 19 coulomb. I will take the whole outside it. So it will be 2I plus 2j plus 4k minus 6j plus 6i. So therefore, the Lorentz force will be 3.2 into 10 power minus 19. It is 2i plus 6i. It is 8i cap, 2j minus 6j. It is minus 4j cap plus 4k. So this is the Lorentz force. This appeared in one of the AIMS question paper. So that's why I thought it's better to take and solve it. So it's not very difficult. Only you have to take I, J, K, 3 mutually perpendicular vectors. And you should know that what is I dot J. It is very simple. See, I dot J is nothing but I, J cos theta. So mutually perpendicular, theta will be 90, cos 90 is 0, therefore 0. Whereas I dot I it is modulus of I cap into cos 0. Cos 0 is 1. Along the x-axis, the magnitude is 1. So it is 1. Like this. So I dot j, in the same way, I cross j and all. It will become sine theta. When theta is 0, it will become 0. When theta will be 90, it will become 1. So it is just, both are just contrast to each other. I think, shall we stop here?